This is practice exam 3, question number 10. What is the energy of 1 mole of photons with a wavelength of 500 nanometers? So you need to pay attention to the words 1 mole. We'll talk about that later, maybe more in detail. So in question 9, we already use this key equation equals C equals lambda nu. So in this question, the frequency is not given. So therefore, from this key equation, we can derive the equation of mu equals C over lambda. All right. And the other key equation that describing light property is the energy equals H times the frequency. H is the Planck constant. Now, the frequency, we don't know that directly, but we do know the wavelength, and we do know the light constant. So therefore, we just replace mu with C over lambda. So now we are ready to do the calculations, because we know C, we know H, both are constants, and then lambda is given in this question. So now we are ready to perform the calculations. H, we just put the number right here, the Planck constant, and make sure the units are joule times second, okay? And then multiply, I run out of room, so therefore multiply the C over W, C over lambda, all right? So C is the constant, of light, speed of light. So 3 times 10 to the 8th units or meter over second. And then lambda wavelength is given in the problem, 500 nanometers. But you see 500 nanometers, okay? You see we have a problem now. This second right here can cancel with this second, all right? But meter, nanometer, they cannot be canceled each other, all right? So therefore, we need to convert from nanometer to meters. So this way you see nanometers are gone, all right? So, and also you see meters and meters also cancel. So what is left for the as a unit for the final answer is joule, just the energy unit. And then that's the answer for the energy of 1 proton. That's what you need to remember, of 1 proton. And what are we asked? We are asked to find out the energy of 1 mole of photon. Okay? So therefore, we need to perform one more step of calculation. Now let's calculate the energy for 1 mole photons. So we take the energy for 1 proton, then times the Avogadro number. So before I multiply by the Avogadro number, I also converted from joules to kilojoules. Why? Because I spotted, in the choices, the answer choices. So that's kilojoules per mole. It's not joule per mole. You see, that's kilojoules. So therefore, I convert from joules, put that on bottom, so that they can be canceled, to kilojoules. Now times the Avogadro number, and then the final answer should carry kilojoules, okay? So I also put mole in the bottom, but anyway, so if you stated this is the energy for 1 mole of photons, you may not need that in there, all right? Okay, so that's the way of solving this problem. So the key thing right here, what the student can easily make mistake is after they finish this step, especially if the answer if the choice contains exactly this answer, so they will just stop right there. And that, of course, is incorrect.